Hello, this is David Hillier here, and I'm going to be giving a short video on capital budgeting, but in particular Monte Carlo simulation. Now, Monte Carlo simulation tends to frighten a lot of people because it gives you a thought of you're going to have to do a lot of programming, you need to know Visual Basic or any another programming language, but in actual fact, you can do Monte Carlo simulation fairly easily just on Excel. And in this particular video, I'm just going to be on Excel. Now, if you look at my previous videos on capital budgeting, sensitivity analysis, scenario analysis, and break-even analysis, then you'll see this particular spreadsheet which we used before. And what I'm going to do is I'm going to talk about this spreadsheet and then we're going to go on and look at Monte Carlo. Now, what is Monte Carlo analysis? Well, Monte Carlo simulation simulates distinct scenarios or observations relating to potential distribution of events. Now, that might seem again very complex, but all you're really doing is having repeated random experiments where your inputs randomly vary, and those inputs go into your profit and loss and your cash flow analysis, and they end up giving you a random NPV. From that random NPV, you can redo the analysis 1,000 times, 10,000 times to give you 10,000 NPVs. And then from there, you can then have a distribution of NPVs. The, it does seem really complex, but I like this method because this method basically takes you to the next stage of sensitivity analysis. It allows you to calculate distributions. And if you do statistics, we say you can't, if you come up with one estimate, that's just one estimate. How do you know how accurate that estimate is? How do you know how, realistic that estimate is? So what Monte Carlo simulation does is that it gives you a distribution of estimates, and from those distribution of estimates, it gives you a good idea of how attractive an investment is. So let's look at this particular case. It's the same one as I've used in a previous video. You invest for 1,500. Your revenues are 6,000. Your variable costs are 3,000. You've got fixed costs that don't change of 1,791. You have depreciation of 300. Subtracting these from the 6,000 gives you an earnings before tax of 909. We then tax that at 28% to give you a net income. And we arrive at an operating cash flow by adding the depreciation back in using the bottom-up method. Now, these cash flows take place between years 1 and 5. So with a discount rate of 15%, you'll see that we get an NPV where it's minus B10, which is minus 1,500, plus using the Excel formula, present value of the rate of 15%, of 5 years because it's 5 year period, and the cash flow in time one is 954. We've got a minus sign to make sure that the signs match, and that gives us an NPV of 1699. Now, these figures are actually derived from some other inputs. So the revenues are a function of the price multiplied by the units sold, but the units sold is itself a variable which is a function of the market share, how much market share you've got, and the market size, what the total market size is. The variable cost is 50% of the price. So what we are going to do now is we're going to come up with a number of different random inputs. In Monte Carlo simulation, you can assume a particular distribution, you can assume normality, but I think in practice you really don't know what the distribution is going to be of your forecast. So I tend to just use a uniform forecast. So let's start off, right? Okay, so in this particular case, you've got four inputs. You've got the price, you've got the market share, you've got the market size, and you've got the variable cost. So what we're going to do is in this I'll increase this to 150. So we'll have market, let's do price first, because price is the first one. Price, and the way I'm going to do this is I'm going to put in the low, the expected, and the high. Now our expected price is 2. So we put 2 here. Now let's say the low price is going to be 1.8 and the high price, what you think is the highest you can get away with, is 2.2. So that's our expectations. We expect 2, but it could go as low as 1.8 and it could go as high as 2.2. We then look at the next thing here is market share. Now market share, because you're producing a new item, you don't actually know what your market share is. So let's say that we're expecting zero point 0.3, but it could be as low as zero point 0.1 and it could be as high as zero point 0.4. So, we've now got this, whereas this was symmetrical, this isn't symmetrical. The next thing is market size. Under market size, we have the expected of being 10,000. We're pretty certain that it's, what the market size is. So let's just put kind of fairly tight bands there for that. And then the last one is the variable costs. Now the variable cost is 50%. So we can say, well, the variable cost goes from, if it's 50%, 0.5, the variable cost could go down to 0.4, but they might actually be more expensive. They might go up to 0.6. So these are our inputs, and these are what we've got here. So what we're going to do now is we're now going to create a number of random variables, and we're going to link that into this profit and loss here. So we have to start off and we say our trial, because we have 1,000 trials, and we'll start off with the first trial. And the first thing we want to calculate is the revenues, but to calculate the revenues we need to calculate the units sold. So what we're going to do is we're going to create random values. Now I'm using a uniform distribution, and I quite like this distribution, but what we've got is it's rand multiplied by, now the way in which you work out how much you multiply this by is you have to take the difference between the low and the high. So here is 0.4. Okay, so we're going to get a random variable that goes between 0 and 0.4, and then we add the low value, which is 1.8. Now what I'm going to do is I'm actually going to make this even better, actually, because what we'll do is we'll say rand multiplied by this value minus that value, and let's put the absolute cell reference here so that when we copy it's the same. So here it's just rand multiplied by 0.4 plus the low value, and again I'm going to put an absolute cell reference. So you see here, this is a very small number. Now the thing about the rand function is it changes every time you enter something into the worksheet. But what we're seeing here is in this particular trial, just this outcome, the price in this event is 1.81, so it's on the low side. Now we're going to do the same for market share. And notice how this has changed now to 1.96. Anytime we enter something, it changes. And the way that I've set the formula up is that it will only vary between these values. So we start off, now look at how we did it. It's rand multiplied by the difference plus the lowest. So it's the same thing, equal rand multiplied by the difference plus the lowest value. So here you've got the market share is equal to 0.3, which is roughly about what we've got there. We now do the market size, and the market size is the same thing. So it's equal to rand multiplied by the difference plus the lowest value. Again, slightly higher, 10,838. And then the variable cost is equal to, again, just the same, the rand multiplied by the difference, adding the lowest value. So let me just check these, right? Okay, I've got all the absolute cell references. Just make sure that all the absolute cell references are in there. Perfect. Now we can actually put together the income statement and the cash flow forecast. So the first thing we do is revenues. So what are revenues then? Well, revenues are equal to the price times the number of units sold. And the number of units sold is the market share multiplied by the market size. So it's the price multiplied by the number of units sold, which is market share multiplied by the market price. So we're told that our revenues are 6,000. Next thing is the variable costs. So the variable cost, just put cost. The variable cost is just equal to our percentage multiplied by the revenues. So you can see it changes every time. So don't need to bother about that just now because we're just setting it up. We have fixed costs. Now the fixed costs stay the same. They don't change, and those fixed costs are 1791. We then have depreciation. Again, this stays the same. It's 300. And so that gives us our earnings before tax. So our earnings before tax is the revenues minus the sum of these costs here. So we'll end up with an EBT of 699,700, which when you look at the net income, it's a bit higher on this. So the earnings before tax is lower here, and that's just because of these outcomes. Tax at 20%, 28%. Notice in this one how it's ended up. The EBT has actually been negative. You make a loss in this particular case. And then we get the net income. Our net income is the EBT minus the tax. We then have after the net income, we then have the operating cash flow. The operating cash flow is net income plus the depreciation. So that's us got an operating cash flow, and from that, and that's the operating cash flow from year 1 to year 5, we can then calculate the NPV. So the NPV is equal to minus 1500 because that's what we were spending, plus, and we'll use the formula PV. The rate is 15%, the number of periods is 5, and the payment is minus the operating cash flow. We need to sort our formula here. So our formula is gives us a negative NPV, and we can see that in the sense that we've got the net income there. Now that here is one trial. Now if we put that to 2 and then to 3, what I'll do is I'll say that is equal to this plus 1, so it goes to 2. If I copy this down, we've got the next. Now in here in particular, you notice here that the NPV is really low here. So what we've got now is I can now copy this for 1,000. We can copy it as much as we want actually. Down, you notice in the rows down the left hand side how we're getting all these different trials. Now that's effectively the same as simulating with a program. And I'll do 1,000 trials, but you could do 10,000. It's no big deal. Let's see. So what have we got? 1,110. I'll just to be correct, I'll just delete these. So we have 1,000 cases and we have 1,000 NPVs. Now what we want to do now is find the average NPV. So the average NPV is equal to an average of these numbers. There are 1,000 cases. You can see a lot of negatives there. Now, the reason why there's a lot of negatives there is because I had a downside risk on the market share because I made that as if that is going to be the most sensitive variable. So I knew that we'd get a lot of negatives there. Okay, so we're nearly getting to the bottom. So our average NPV is positive. So in this particular case, we're getting a positive NPV on average, but that doesn't really tell you much because what we're wanting to do is we're wanting to do a histogram of this function. Now, the the really annoying thing about Excel on the Mac is that you don't actually have histogram function on it. The PC, it does have it. So what I'm going to do is I'm actually going to port this into an alternative package. And the alternative package, the package that I'm using and I use for my research is Strata. So I'm going to copy this, and I'm just very quickly, I'll just copy this in. But you could copy this series into any software package you got. But if you've got the PC version of Excel, then you can just use the data analysis tool pack, and it will give you the histogram function. So I'm going to copy, and then I'm going to go up to, let me just delete that, drop variable. And what I'm going to do is I'm just going to go into the data editor, and I'm just going to paste the variable in. So you see here that this is just the NPV here. And then simply I'm just going to get a histogram of the NPV variable. So what you can see here from that histogram is that we've got quite an unusual distribution here. Although the average NPV is positive, a lot of our scenarios are leading to negative NPVs. So that would give us a bit of worry then, because clearly we then say, right, okay, well, we've got an issue. So what is that issue? And this is where you start looking in more detail at these inputs. So we might actually then say, well, let's do a bit more research into finding out about this market share. And again, this is when from the Monte Carlo simulation, you then move into a sensitivity analysis where you look at how these variables might change. But if I put this value to 0.2, you'll see that the NPV average goes up significantly. And if I was to copy this, I'm going to have to copy it again. Just with that change in our low estimate, that will have a big impact on the distribution of our NPVs. So that's Monte Carlo simulation. I've shown you how to do it quite fast, even without any programming knowledge. You can do Monte Carlo simulation. If you want to get a bit more fancy, you can start using distributions. Using distributions, you can then have, instead of having just a uniform distribution like I did for each of the inputs, you can put in a specific distribution for the let me just delete this. Yeah, no. So I'm going to post this one in, put in variable names here. There's a problem naming, so we've just called it NPV2. That's and what we're going to do is we're going to do a histogram on that one. Now that's um, a revised graph. So just variable 2, click that, and look, you've got, compared to the uh, the other graph that we used, if we do, let's just see this one. Okay, yeah, I'm messing about here. Okay, so if you look at this graph, then you'll see that this one, there's still a lot of negative NPVs in our trials, but we don't have that many. So clearly, market share has a big impact on what we're trying to do. So bringing everything together, coming back to the Monte Carlo simulation, it's fairly straightforward. And from this, you can really go into a capital budgeting analysis in a lot of depth. If you think, right, okay, we can actually try and keep our variable costs down to a little bit more, you can see how the NPV goes up, and you can see that the number of negative NPVs drops quite substantially there. And that is the next stage of capital budgeting analysis. You do the first, you get the cash flows, you then can simulate using the number of inputs, and you could make that as complex as you want. And then from there, you then do trials, and you do as many trials as you want to get a distribution. That distribution tells you so much about risk and forecasting risk. So it's a really good method, and hopefully this video has been of some use to you. Thank you very much.